right, hi everyone. It's really a great honor to be the inaugural recipient of the ACM-W Rising Stars Award. I wanted to take this opportunity to share with you some of the research that I've done over the past few years. In particular, my research has centered around, a wide range of compute-intensive applications, ranging from video compression to deep neural networks to autonomous navigation. What brings all of these applications together is they typically involve a very large volume of data that needs to be processed. The algorithms used to process these data tend to be very complex or increasingly complex to achieve higher quality of results. So for example, better compression or higher accuracy. And then from a systems point of view, they often require processing to happen at a very high throughput or low latency. And if they're on portable devices, it also requires, improved energy efficiency. So as a result, my research is centered on enabling efficient computing using the co-design across algorithms, architectures, circuits, and systems. So this journey began by looking at how do you do low power design for video compression. In particular, we were looking at scaling down the supply voltage so we could reduce the energy per operation, but this comes at a cost of increasing delays. So then we needed to use parallelism to recover the loss in throughput. This enabled us to significantly reduce the power consumption required for video decompression. In particular, we could do high definition H.264 video decoding in under 2 milliwatts, which is 6 times lower power compared to state-of-the-art results. Now, not all algorithms can be parallelized. In particular, if you look at more advanced algorithms, they're difficult to parallelize because, often looking at video coding, you're actually removing redundancy to compress, which introduces dependencies. So we really had to rethink and redesign all the algorithms to make them compress well as process efficiently. In particular, for my PhD, I focused on the entropy coding engine called CABAC. We really want to focus on removing as many of the feedback loops as possible while still being able to compress well. Later on, when I worked on the video compression standard at Texas Instruments, we really focused on developing tools that are both improving coding efficiency, so improving compression, but also very efficient to implement. So need to satisfy the two of those. And so again, this is a prime example of the co-design of algorithms and hardware to address coding efficiency, throughput, and the power challenges. Now, when I returned to MIT, I want to shift from compressing pixels to understanding pixels. And really the state-of-the-art approach to understanding pixels is using deep neural networks. In particular, when you're starting to think about the hardware needed to support or process deep neural networks, you realize that most of the energy is consumed by data movement and memory access. So you really have to figure out efficient ways to process the data, in particular efficient data flows to minimize the data movement. In collaboration with Joel Emmer, we designed the Iris chip that allowed us to achieve image classification in under 1/3 of a watt, which allows us to achieve an order of magnitude energy reduction compared to mobile GPUs. Another area where understanding pixels is critical is autonomous navigation. One of the key steps in autonomous navigation is robot localization, meaning figuring out where you are in the 3D space, as shown here on the right-hand side. And so in collaboration with Surtesh Karaman, we designed this chip called the Navion. It was really a co-design of the algorithms and the hardware together to basically integrate all the processing on chip, but also to minimize the amount of storage that we needed on chip. So this required changing the algorithms themselves while maintaining accuracy. So I really want to highlight the fact that a lot of this work that was done was in collaboration with folks, beginning with Daniel Finkelstein when I was a PhD student. He was a fellow graduate student in the lab working on low power video compression. I also want to thank my advisor, Anantha Chandrakasan, who's really a pioneer in low power digital circuits. And he was always very, very supportive and encouraging of me, in particular, encouraging me to pursue a faculty position at MIT. I also want to thank Madhupar Budakavi and Minhua Zhu. They were my mentors when I was an intern at Texas Instruments and taught me a lot about video compression. And then when I joined as full-time, they were my colleagues, and together we worked on the latest standard, HEVC. And that standard actually received a Primetime Emmy Award itself. I was super lucky that when I returned to MIT, I also had great collaborators to work with. I first and foremost want to acknowledge Joel Emmer, who's been a great collaborator, friend, and mentor throughout this entire process as faculty. I also want to acknowledge Surtesh Karaman, who's also been a great friend and collaborator on the robotics work. Now, all faculty members know that the key to great research is having great students, and so I want to acknowledge my wonderful students and my great team at MIT, and I want to mention that these students are also very brave because often our research happens at the intersection of very distinct areas, and they've been very brave in terms of taking on this challenge and really pushing this work to the new frontier. Finally, I want to say that, a key important thing for great research is also a great community. I want to acknowledge the WIC-ART Society. They've been super nice and welcoming to me. I actually, joined this architecture community when I returned to MIT, so that's kind of midway through my career, and they've been super welcoming. I also want to thank the Women's in Circuits community in the SSCS Society. This was led by Alice Wang, who really founded this community, and Alice has also been a very great mentor and friend beginning from my PhD onwards. And then finally, I want to thank Andrea Goldsmith, who established this award, and she's been a great role model to many of us. Thank you very much.